already start the video, so. Let's walk up there. Hi, good morning everyone. I'm Niko. How do you do? I won't remember names. I'm terrible at that. It'll take me 6 or 8 times to meet everybody before that settles in.
Yeah. So welcome. So this is a conservation agriculture class, and we've basically been talking about. We've met for the last 2 days, and we went over federal conservation law and programs, and then yesterday we talked about all about Vermont and the RAPs.
Okay.
And state programs, and so it would be great if you could take us around, and especially pointing out like where you're doing conservation practices and where you might have gotten financial assistance, where maybe you pay for it yourself, and kind of the whys and how that all works and fits together for you, and if the RAPs are anything that you consider as you move animals around and do things on your farm. So anything like that.
Yes.
Super helpful. We also talked a little bit about PES, so if you have anything you want to share on
Yes,
ecosystem
that's a sore subject. So just to sort of update you, or all of you, we were part, 3 years ago we applied to the pilot program that the state of Vermont initiated. It's called the Vermont Environmental Stewardship Program. We just got our certification on that. We scored 100% on it. We're the only farm to do that, together with a small dairy in Franklin, up at the Canadian border.
Shire, how do you say his last name?
Shire.
Shire, yeah.
That's great. Yeah, it's pretty cool. They're a much smaller farm than we are. We're sort of in the small, on the large side of a small farm, and then it goes up there. So we just sort of animal capacity wise, we're what are they called? It's a USDA grant.
The Conservation Innovation
Grant. Thank you. CIG. And it's a 3-year grant, and what we're doing is we're measuring deep soil carbon sequestration on this farm, at Butterworks, and at Lucas Cattle Company in Orwell. So we have 3 different soil types, 1 dairy, 2 beef farms, and we planted intermediate wheatgrass, which is the same species as Kernza. You have heard of Kernza? You know what this is? Yes? Okay, no. So Kernza was developed by the Land Institute West Jackson's breeding program, and basically it's taken intermediate wheatgrass, which is one of the ancestors of wheat, and a perennial, and has bred that to about 50% of the yield of commercial wheat and a protein content of about 13%. Hard red wheat is about 18 or so. Baker's, baking quality wheat. So you can do soft breads or muffins and stuff like that don't need high gluten content to form that elastic bond. You can use it for beer. You can use it for us. Patagonia actually carries snack bars made with it. And anyway, so it's starting to become a thing. But it's basically perennial wheat. And so every year the wheat just grows. You harvest the wheat, and there's the plant, and it can make deep roots. And since this intermediate wheatgrass is originally from the Middle East, it's very well drought adapted. It was introduced a long time ago into the United States. It's all over the West, and it can survive on, I think it is about 14 inches of rain. We have about 40 here. So we don't know how it does with the freeze-thaw cycles. They're pretty harsh here. Anyway, so we planted 5 acres of intermediate wheatgrass just because it's very expensive. It would have been nice. But genetically speaking, the plant is the same. And they're getting radioactive isotope marked. So we can say, oh, this carbon molecule came through this plant, and this is how it got down there. And you see there's a $70,000 instrument out there that Dartmouth just put up. It's called an eddy covariant tower, and it measures real-time flow of CO2 in the air, temperature, humidity in the soil and in the air, and then there's a formula, and you can say, this was available, this is the percentage of carbon we captured that was available, and we're putting it in the soil. So it's wicked cool, and we're going to get data that's actually new, that it doesn't exist. Most of the soil tests measure carbon in the first 4 to 6 inches, and we're not seeing the results we want to see here. in terms of carbon sequestration because we get so much wash. And so to explain that is like when you have the photosynthesis cycle, the plants make sugars, which is carbon, right? And so carbohydrates, and they go into the roots, and there they get traded with the mycorrhizal population to the soil microbiota, the life, bacteria and microbes and stuff like that. So it's basically a swap. And what do they give back? They give pre-digested bioavailable nutrients from the soil back to the plants through the mycorrhizal network. So there's a trader class, there's a supplier and a consumer in both directions, which is kind of interesting. And this is a fairly new discovery, I would say maybe at most 10, 15 years old, that we actually know how this works. And we're still learning a lot in terms of the science. Elaine Ingraham is probably the most well-known US-based scientist who does work on it. So what happens is when that carbon is in that transportation state, it's liquid, and it's not consolidated, it's not stable, it's something that can be moved around easily. And so that happens in the first 4 to 6 inches where we get all our rainfall saturation. It just gets washed and dispersed and is not available in the same way. So the deepest rooted native plant, the orchard grasses, are about 18 inches of roots compared to Kernza or intermediate root grass, which can go 12 feet. So what we're trying to do is we're trying to introduce plants that draw this carbon down deeper so we can stabilize it and use agriculture as a carbon sink. Why is that important? Because Elon Musk and all those guys that, what is the airplane guy that,
Branson?
Yeah, Branson. He's into this kind of stuff too. What they don't understand apparently is the basic, simple, or it's not that simple apparently, thermodynamics, right? There's entropy. Every time you change this energetic state of something, you use more energy than is embedded in the process. And so if we use any technology that is energy-based to draw down carbon, we have to supply more energy than we're sequestering. Where's that energy coming from? Well, it's an entropic process. So unless we come up with an energy source that doesn't use fossil fuels, which we don't really have, or exploit, solar panels are just an extension of that because it's not free to make them, right? It takes a while to draw that down. So the energy equation sucks, essentially. Biology, however, doesn't have that. It's an inherently stable process, energetically speaking, because it otherwise wouldn't be self-propelled. It wouldn't be going on for millennia. So what we're trying to do is tweak biology and give it a little bit of a boost and manage it so it accomplishes the human goals, or our goals of forming and creating a more symbiotic relationship with the environment. And there's a huge philosophical difference in thinking about that. And so that's what we're trying to do with proving this, that we can actually take carbon with cows and put it in the soil and sequester it so deep it doesn't become immediately bioavailable again, which is sort of like a similar idea as putting it into trees. But these trees, like the biggest trees in this fence row, they're 125 years old. And they're still in that cycle. And once trees are stable, they do sequester some carbon, but not nearly as much. Whereas here, we do 5 or 6 rotations with the cows over this land. And every time we pulse that grass down, there's another sort of, I call the cows bioaccelerators, right? They just tweak its cycle and up it. So by managing the cows in a different way, and not just putting them out here and coming back in October and saying, oh, you're still alive, great, come with me, where they eat all the ice cream, kill all the good plants because they overgraze those, and after a while all you have left is weeds because that's what they don't want to eat. And we do this management completely differently, and thereby increasing the cycling of the biology, and thereby gaining more out of the same system. So that's the idea. But the numbers aren't there to prove it. We know it works because we can see it. We can dig a hole here, and we've done that. You can look us up on the Soil Carbon Institute's website. There's a marker. It's right there. And laid out a grid. Did the infiltration tests, measured the organic stuff, and we need to do one again. This was 5 years ago, so we have a baseline, and now we're doing all the testing and documentation so we can actually say, yes, what we do works. And if our estimates are right, we, with 40 cows or thereabouts, sequester about 8 transatlantic flights of carbon every year. Which is not huge, but it's a lot better than a lot of other people do. So, so that's the idea.
Yeah,
So
are we gonna move? We've been talking a lot about the difference between modeling and measuring and sort of the inherent difficulties of both and the expense of both.
Oh yeah. I mean, so there are systems that do real-time monitoring of farms, which are very, very interesting. They cost about $1 million per farm. Actually, you can use them by watershed, because watersheds tend to be similar enough that you can extrapolate the data. We've already got 8 provinces worth. And I mean, there's some really cool stuff, and I think we're going to learn a lot about that. The huge danger is getting co-opted by industry, and the fight really right now that's there is who owns the data, and if the farmers don't own the data, they don't get paid for it. And that's really where it boils down to. If we want to have a say in how this gets how it gets monetized, we need to be the owners of the data. But I mean, this all gets us to a much deeper point, right? Is there's a fundamental incompatibility between agriculture, sustainable or regenerative agriculture, and capitalism. They don't speak the same language. I mean, there's nothing wrong with making a living. There's nothing wrong with having money as a transactional system. But if we set it up in a way where the basic resources aren't monetized in the system that regulates how these exchanges work. So in capitalism, a resource only becomes valuable when you exploit it, not when it's here. Like, there's no money in the system for good water quality. There's nothing there for preserving soil quality for the next 100 years. There's nothing there that rewards nutrient density in the output we produce. You know, all those kind of stuff. If that isn't included in the monetization of the system, then we're never going to fix it. So that's really a shift, and we're seeing a little bit of thinking going that way, but most of the policy work is still about the carrot and the stick approach, and it doesn't really shift the whole understanding of how the system works. Or doesn't work.
Because it has to be viable. It's expensive to do it right from the get-go, or to shift. It's expensive, and it's a lot to take on just personally.
I don't know if it's expensive to do. It's a completely different philosophy. We don't actually know if it's expensive to do. I would argue what we're already doing is super expensive to do. We just haven't gotten the bill yet. You know, it's like we're starting to get the bill with climate change, but it's going to get a lot worse. You know, it's sort of like a balloon mortgage. You know, you don't pay anything until it hits you at the end, and it's like, shit, now I own $500,000, and I have to scrape all of those together in 1 year. And we're sort of so. Long term, I think actually the regenerative system is cheaper, but there's such a philosophical block, and there's a huge sunk cost in the investment, and that's, you know, we all know what that's all about. We know that in our personal relationships, we know it in stuff, you know, what is the opportunity cost and what's your sunk cost and what's the balance. It's hugely difficult to make those decisions. Even just for one person, never mind a whole system, right?
If you want to pause, and then when we get to the
line that ran all the way from where my truck is parked all the way to where that road is, and that was attached to this. So it was a huge cross gable here. It was where all the heifers stayed, and then this was the milking barn. So we took all that down because it's all falling down. The base carrying beam on it was a 46-foot long, 13 by 18 hemlock. So that's the trees here then. To put another greenhouse in, which is going to go right here along that. You can see there's a section of that beam I was talking about sitting right there. Too long for the excavator to pick up that big beam.
high tunnel program, and so it's essentially a greenhouse. They call it a seasonal high tunnel, and I guess the resource concern that it's addressing is to extend your season. So
right, but
it's
they
a little
don't pay for any of
questionable.
the site work. They don't pay any for any of the
You gotta
end
put it up
walls. They don't
yourself.
pay any for the mechanical system. It's really just steel and plastic.
Uh-huh.
And if you want to have double layer plastic, you know, you can do whatever you want, but their payment rate will cover just a very basic greenhouse. What we're going to do here, we're going to do the same system we have that I described up there for that greenhouse up there. I'm going to excavate this 8 feet deep, put pipes in, put it back, and then put topsoil on top, which is sitting over there, spread that out, and then have that seasonal heat storage system. And then what we're going to do is we're going to grow. Nobody does this in New England. Our main competitive disadvantage here is cold. Like when you say, oh, California, they have such a great climate, they can grow everything. They only can because water is free, and they're going to run out of it sooner or later. So we'll be ready. Well, I mean they're pumping 12,000 feet now, I think, in the south and central valley. So they're going deep, for water. And the Sierras have actually changed height geologically speaking because of the water extraction. So it's geologically relevant, which is pretty interesting. Nobody knows how that affects like earthquake response, because water has a buffering capacity there. So we'll see. And so by taking away the high peak heat costs to produce winter greens here, this becomes a way more compelling system. And we haven't received the grant yet, but we wrote a grant to document that with Dartmouth students from the engineering school, so they can monitor all of that and actually come up with saying, okay, here's what you're saving, because we're not putting a traditional greenhouse heating system in, but we're hoping to be able to produce stuff probably into early January and then starting again in March, just with that system. And then in the meantime, we just are in survival mode. So the second restriction on plant production is light. We just don't have enough solar to make plants grow, and we're probably not going to address that, at least not in the first step, because it has a lot of costs involved with that. But the way to then grow plants in winter is to take remains, sort of this white stuff that you put over plants in fields and growers. It keeps insects out, it's water permeable, so water can get through, and it also limits air movement. So it makes things like a microclimate that's more humid and warmer. So it's often put across melons and so a little bit more tender crops. And what we're going to do is create an automatic retractable system of relay over the entire greenhouse, so that in the nighttime we can cut down the air volume, or when it's cloudy and cold, and just heat this much, because the plants really don't need 12 feet high gables. That's what we need to get a tractor in the greenhouse. But there's no reason to have a greenhouse. I mean, if humans were shorter, we could work in a much shorter house. But it's greenhouse is the only constructor for human benefit. Like the plants don't care. The greenhouse, all they care could be destroyed.
So we need to change the child labor law.
That's a classic lawyer's perspective. That's This is orchard grass that is, in its full maturity. So this is the one that goes between 18 inches and 3 feet deep in their rooting. Come on.
Yeah. I have a You can pause while we walk.
You can look at it. It's called Eddycovarium.
Eddycovarium. Okay.
It's Eddycovarium towers. They have been used by the Forest Service and other places quite extensively. Dartmouth, there's the team that we wrote the Conservation Innovation Grant with, they just wrote a second grant for $750,000 for 2 more towers, one at Stonewall Farms in Connecticut and the other one at a farm in Maine. All comes, if we get this grant, it comes with visits of the farmers to different farms and dinners hosted there, so I can't wait to get fed. So yeah, I assume that everybody knows what I'm talking about when I say Stonewall Farms. It's a huge non-profit foundation that's owned and oh God, what is his name? What's it? Maybe now. That's just part of it, probably. But come on, what's the name of the chef who wrote the third? Darren Barber. Thank you very much. He's the one who runs it and wrote the Third Plate, which is a really seminal book about understanding the food system. And in my opinion, way better written than any of Michael Pollan's books, which are good, but Byrne, yes, but he's a really good writer. I mean, maybe because it was, I don't know. I really enjoyed it, and it's really changed the perspective of like what the culture is. Try to do it as much as possible. This is the wet swale that goes through here, and you can see. Has regrown where they would have grazed it here, because this is all new growth here. We already have 12 inches of growth in 10 days. We don't graze it down that much, so there probably was this much left. So a 10-day recovery of like 4 to 6 inches is amazing. And you can bring these cows in again in about 3 weeks, and this will be incredibly dense. Sometimes, we go through after the second rotation and we clip all the seed heads, because it gives the plants, well, there's a biological imperative for reproduction, right? And once you've accomplished that, you die. So, not unlike humans, there's a hormonal change in the plants, and they just don't produce the same rigorous growth anymore because their seed production has been accomplished. So, at this point, they're still, they've been pollinated, right? There's no more pollen here, but the seeds aren't fully formed. So if we clip them now or shortly, then they will say, hey, what happened? And they'll start growing.
So can you give us some numbers, like how many acres, how many head?
So we raise about 30 head right now here. This is about a 60-acre field. So it's understocked for just grazing it. There's a little bit of confusion in our planning process for this year. We're going to, it's a long story, but the project might still come together in a different form. But the idea is to create native land access and stock this with bison that were coming from Yellowstone for a genetic diversity program or genetic relocation program. And all the buffalo genetics in this country are concentrated in 25,000 animals. Even though there's 1.2 million buffalo out there, or bison, they're all polluted or interbred with cows. And so the genetically pure bison are very few, and they're all located in a very small geographic area. So the idea is to bring them to other places so that if something happens to that population, we don't lose the genetics. And that was in conjunction with the Abenaki tribe. Look at these cows, they keep the fencing.
What?
Well, there probably wasn't snap on it, and so then the calves just go and chew on it.
Look like NRCS fences.
These are NRCS fences. They paid for these fences 3 years ago. That cost them about $40,000 to fence this place with a 3-stand electric fence.
Got it.
Oh yeah, no,
So how did you manage to get that? You had a grazing plan already. You had, this field had it been cropped, and you were changing it into, so you were taking this out of crop and putting it into hay,
it was hay, but there was no fencing. And so there were, this all came to pass because we went to the Vermont Land Trust Conservation Program, and donated the development rights for this, and so as part of that they said, well, you fence out all of the stuff, and I said, well, I need the money to do that, and so and then the NRCS stepped in and made that complete because So that's why the fences are also set back much more than in some areas. You can't see it so much here. But we lost about 6 acres of graze in this field because of the setback regulations to preserve, buffer zones and all that kind of stuff. So here you see these tree islands. There's some stuff still growing there. That's sort of the savanna stuff I was talking about earlier. We were trying to raise trees that then change that. Why do we want to do that? I get asked this. The old timers stop and say, "You're ruining this beautiful hayfield. Why are you putting trees in there? Can't hay with the trees in there." And I said, okay, so where do I start with this? So a lot of the grasses we have here are C2 carbon grasses. They're cold season grasses. They grow very differently. And they actually like a semi-shade environment, especially in the summer because it gets too hot and dry, and then they stop growing, which is what we call the summer slump. And it starts right about now. Maybe a little bit later, depends with global warming or climate change, it's a little hard to predict, but typically mid-July through end of August, they just don't grow. It's too hot and too dry. And then as it gets cooler, with colder nighttime temperatures, they start picking that up again. And so what we're trying to do is with tree lines, again, along these semi-permanent fences where we just crossed, they're pine trees and willows and all sorts of stuff. That's all buried in the grass right now, but we're trying to slow down evaporation rates by slowing down the wind speed across the land. That's beneficial in summer and in winter, and we're creating shade eventually, which both the cows and the grasses appreciate. And if we ever wanted to hay this, which we have, we contract that out, and the guy comes, and 2 days later this whole thing is cut and baled. And why? Because we wrap them to preserve the nutrients, and so the hay doesn't have to get dry to the point it used to be for a dry barn storage, because it would otherwise ignite your barn when it got hot and started fermenting. Now it's in a bale and it's fermenting and it's fine, and it actually preserves the sugar content. So we typically have about 5 to 6 percentage points higher protein, and we have vastly more sugar preserved in the baleage than we would have in dry hay. So it's a win-win for everything, essentially. And so the savanna principle is something that they've started sort of redeveloping. There's an institute out there called the Savanna Institute, and I think they're in Wisconsin, and sort of reintroducing cohorts of and guilds of plants to each other that support each other in terms of creating sort of micro bio islands that then help the biodiversity, wildlife access, also human food, and again, climate mitigation by slowing wind down and evaporation rates down. And so there's 3 out there, there's 2 here, there's 2 over there, and then there's 2 long, multiple thousand feet long tree lines that are going in there. And again, we're going to have to do it again. We put, I think, 1,400 trees in 3 years ago, and that was a drought year. And so, that's something I would love to see conservation practice money for. It's unfortunately not available. They're very conservative in terms of which species we can plant with their money, and a lot of the trees that we want to plant are not part of it. It's more the money of the NRC is more focused around riparian buffer zones and stuff like that. So that's the species selection we have, but that doesn't really work so well in the middle of the field. So we have a bull in here. If a bull looks sideways at you and starts throwing dirt on himself, you retreat peacefully. Okay. He won't charge you or anything. He's very sweet, but he might get annoyed a little bit. Okay. Yeah, don't worry. I'm not here alone. Don't walk through this field by yourself. What, you gonna say hi? Yeah, you say hi to them.
Aww.
Go say hi.
Are they your friends? What's this one's name?
That's hi.
Pi?
Yeah.
Hi, Pi.
Hi, Pi. Yeah, like the mathematical constant.
Oh, that's kind of. I thought because he was the color of a pie.
Well, maybe. But...
Hi, guys.
Yeah, go get her. Yeah, you go get her. That's right. Yeah, go get her. Go get her. Go get her. Yeah. Oh, there's my second bull. I was wondering about that. That's why the fence up there is done. You can see that the closest one with horns. He was up with the other cows. I'd separated his two bulls, but apparently they like each other, fighting with each other enough to just want to hang out with each other. That's quite the feat. There's 4 permanent fences in between there and here. So. Huh? Adler, what are you up to? Yeah, you have to go to that. So you can see it gets really dense here. You know, we have when we bought this land, it had been hazed basically much continuously since the 1940s, and we probably doubled density and yield since then, and plant diversity. I mean, it's really hard. You really can't see the ground. I mean, here's some hay or cut grass that got left here. So you see some spots here. But this is a pretty dense grass band, and even if you dig down to sort of the bottom, there's litter there. So again. So we did see some ferns right here. I'm trying to find it. It's probably not very tall yet. The plant grass identification is the worst. Like once they set seeds, it's really easy. Before that, it's really hard because there's like 5 or 6 different species of grass that look very similar in leaf structure. So I don't know if I can find the cleanser right now. But let's walk up to that tower and we'll talk about that a little bit. There's another program we participated in the past, and it's called the Audubon Society's Bubbling Program, and you get payment to
not cut.
You get paid for not cutting your hay or not grazing, and
until like July or something.
Well, it's 8 weeks, and it starts either June 1st and goes through August, or it starts mid-June, goes through mid-September. And the economics don't work with the program. We've pointed it out to them a couple of times. The effect on the bobolink population is great.
So the purpose is to leave habitat for bobolink goats, which are ground nesting
birds, which if you cut hay, you're going to slice that, right? Because you're cutting really short. What we proposed to them, but because of COVID never got going, and this spring we sort of missed the boat because nobody knew what was happening with the COVID thing and was it even possible, and getting people organized. But the idea that we pitched to them is like, you need to change how you pay for this, and we're going to demonstrate that with rotational grazing we're actually getting a bobolink population to survive, because the cows will not step on the nest if they can see it, and also the density of how we graze is just not that intense. It's not like haying where every square inch gets mowed, and that we would have half the field in their original program and half out, and see how many of the fledglings survive. But it's hard. Yeah, it requires a big commitment from a research team to come here and count and observe and stuff like that. So we haven't. They're in principle they're very much open to that because they want to make it work for farmers, and they're realizing that with the amount they pay, they're either playing into commodity or into they're paying rich people who are already not farming and just setting them aside, and then they get the money to brush hog it in the fall, and it's like, yeah, that's a win. Not, but so I think they're cognizant of the issue of how the program is achieving one aspect of its goal, increasing bubbling populations, but it's not achieving the other one, which is fairly compensating farmers for the loss. And it's
so you would be basically missing, like in a typical hayfield, you'll cut at least 2, maybe 3 times per year, 3 times for sure.
At least, yeah.
And you'd be missing 1, maybe 2.
No, you miss 2 cuts, and that's the problem.
Cuts.
Is that, because typically your first cut is in the first week of June, second cut is 4 weeks later, and then third cut would be, depending, early September usually. So the problem is that you get the cut, but the quality of the forage is so low that it's just isn't the same nutrients you're getting. So the payment you're getting is not enough to make up for the loss of nutrients in terms of your cow feed. This year probably wouldn't have mattered much because everything is so late and people are just starting to cut. You can see it's like everybody's way behind. Typically, and like regular years, we would see first cuts between June 4th and June 10th, and people are just doing their first cut now.
NRCS has a delayed mowing practice also. I wonder how it shakes out money-wise compared to the...
Oh, interesting.
Is that National Fish and Wildlife? Or...
No, this is Audubon.
Oh, Audubon.
Yeah, so it's privately funded.
Yeah. The money shakes out.
It's actually interesting because it's an auction process, the way it gets funded with Audubon. So you tell them what you're willing to give up monetary-wise for it, and then they group it, and then come up with a median, and it's a fairly complex. It's a complex bidding game. It's like game theory. You go into it and study philosophy and look into game theory or mathematics. That's exactly how they're applying it. It's actually quite fascinating. It works okay. The problem is that the farmers competing against you are either not farmers, so they don't need the money, or they're farmers of the old school that don't, or they don't have carrying costs for land because it's a family farm that's paid off. Or they don't do the real math of what it costs. And a lot of farmers are really bad at cost capturing. And you start capturing the cost, then it's just marginal. Yeah, she gets allergies and breathing pollen.
So that's your barn up there.
Yeah, that's the house we were up there. Yeah, exactly.
Oh.
So our land goes from the river, and then it goes about another, I would say where we were, it probably goes another 3/4 of a mile up the hill. So we go from 1,200 to 1,850 feet in elevation. So it's sort of a wide swath, and it's just, you can't get there from here, and so that's why we have 2 road addresses to confuse visitors. Yeah, and I think what's interesting to note here is if you look and see, it's been really dry this year. We're still in a drought. We've been in a drought since last July or end of June, and we're not out of it. So we're in a full 12-month drought cycle, and it doesn't look like it's going to stop anytime soon. But you see how green this all is down low, and how comparatively wet on fairly dry soil. So this is the Eddie Cavarian Tower. There's a cell tower across the valley that it's linked to. It produces its own juice. I think they're still tweaking it. I'm not sure if it's actually measuring anything right now. But you can see it measures the flow of the air between those 2 things there. And it also has a methane analyzer that you can put in there. I don't think they have installed it, but you can do quite a bit of fun stuff here. And I'm sure the cows would just love to knock that thing over and eat it. We're going to have to build it a little bit more onto fences here so that they don't run into that, especially with the bulls in here. They just shove each other through a fence.
That's an expensive toy.
Yeah, that reminds me, I need to call my insurance guy. Put that on the policy.
Right?
I'd rather not start with 50 grand.
No, no. Should be their insurance.
Yeah, sure. But you know how that goes. They all blend each other. And it's not going to cost anything to put it on there. It's just as an additional insurance, right? $30.
Yeah, that's smart.
That's all the nutrients in the soil.
No, and measure real-time CO2 flow. And then correlates it later on when we analyze what we have in terms of changes in the soil carbon. We can say we got so much CO2 coming by, we captured so much of it and sequestered it. And that's where we get. You see there's a locust tree there and there's some other bushes in there. So that's part of these tree islands. There's another one out there. You can see there's something growing that's coming out of the field there.
So a super important part of any grazing system, if you're going to be moving your cows around to all these different fields, is making sure that they have a watering source. Did you get any of your pipes or your, wells dug or anything like that?
We had some money from NRCS to revive the old milk cooling well that they had for the house before they put a deep well in. We can walk through the yard by the house and you can still see it. There's a big cement trough that had flowing water continuously flowing through it from that well that you would put the milk cans in and cool them so that when the milk truck came and picked them up, they were cold. That's all 1940s and 50s. And before, we had bulk tanks and stirrers and refrigeration and stuff like that. So the NRCS paid to rehabilitate that well, and they did pay some money for piping. So what we did is we have water line, thousands of feet of water line everywhere, and then we have these connection points. From here, so there's a connection point here. Oh, you can't see it. So if you want to see it, you have to come over here. It's basically, they're called plastron valves. Just step on the fence, right? Foot on top. There you go. That's the safe way to get over that. And they have, if you've ever seen like a mechanics shop where they have like air hoses that they plug in air tools, when you get your tires changed or something like that, this works the same way. It's an automatically shutting valve that you open with a plunger that activates the water flow. The pipes are constantly pressurized with water, and then I just move the tanks around and have these takeoff points that are marked with sticks so I can find them again. And then we just plug in the tanks and fill the water. We have a takeoff point every couple hundred feet, and so we can be very flexible about where we put cows and water access. That's really the biggest thing. And the beautiful thing is I don't have to drain these lines. These things are frost-proof, even though they're plastic, they don't break. I've mowed them a couple times. That does break them. But they're incredibly tough and cheap. So it's definitely something that's, very appropriate technology that very, very few farmers use because they don't know about it. The cost of the water system is really cheap in the scheme of things. Definitely something for you to do maybe with your, with Amber, we can do a technical thing, when you get into that, because that's like the keystone. If you don't get, I can't get water there. That's the biggest excuse I hear. And yeah, you usually can. You can put pressure reducers in, you can put booster pumps in that are solar on, there's all sorts of things you can do to move water around where you don't think so.
Right.
We ran one down the hill with so much pressure on it that it blew the valves apart. So now we run the greenhouse water system pressure reducers on them. Works great. That was actually Amber's idea. So.
Nice, yeah,
She's very, very on. Well, let's walk through here. I'm gonna show you some other stuff, land management stuff.
I want to people report from the second time.
Oh, you can give her half.
Come on through.
Oh no. Okay, well then never mind. I'm not giving her half. She ain't taking my money. She already has enough money.
So you can see there's sort of an open forest edge here. You can see it looks different than over here. It's because that was one huge red pine stand, red pine on the trees that are across the valley there. You can see them, and they're all getting mature to the point where they get diseases. And there's also a fungus disease that sets on. And we've been trying to log these for a few years, but the pricing of the lumber markets was not there, and this winter it finally turned, and so we cut them and we had them stacked next to where you parked up there, so you can see them, and they go for plywood construction to Canada. But you can already see this. I mean, this was just done last fall, and you can see there's already the succession trees, the maples and the beeches and stuff, and some ash that is coming back or is in there in the understory. I'm thinking of planting some Korean pine nuts in there.
Ooh.
We have a few that we bought, and they're doing pretty well because they will produce a food crop, and the acidity of the soil, because there have been pine trees there for the last 30 years or 40 years. Farmers used to get paid by utility companies to plant them for utility poles. This is in the 40s, but now they don't care. They just import them. You know, there's so much trees cheaply available in the West. They don't use the red pine anymore. But that's why you see these stands of red pines on farms all over the place in New England, because that was like an incentive program that they did for a while, and then never followed through on it. But because of the acidity is already adapted to pine trees, it's probably going to help establish something that like similar soil structure. Let's walk through. Two dairy cows up there that are
Maybe
just
because I have way different legs.
for fun. And I make cheese. And,
I don't make a habit of staring at
all
legs.
sorts of other dairy products with them. And one of them just calved like 10 days ago, and that's why I was asking her where her calf was. And the other one isn't due for a while or didn't get bred. I'm not sure. And these are all dual-purpose cows, but with a beef emphasis, and that's why they're managed differently. They don't have to go into a barn on a regular basis.
Yeah, a lot of people say
and
they're
stuff like that.
really young.
So they can roam. So rotational grazing with dairy cows is a labor-intensive business, because you have to run them back to your barn where you can milk them, or you have a mobile milking parlor which has its own challenges. So either you bring the equipment to the cows or the cows to the equipment in order to make that work. And Jennifer can tell you more about that, because she's planning a whole big change in terms of finding a few farms and getting them to from confinement to a grass-based system over the next 3 years. So it's a pilot program. It's really cool.
Trying to pitch farmers on the reduced workload, reduced feed cost. Those are kind of the main pitches, I think.
So the milking becomes a little bit more ornery to manage, but you save yourself all the machine time to harvest the food, right? And all the machine time to clean out the barn and all that kind of stuff. And it's also there's proven benefits if you take replacement heifers. So it has a benefit for longevity of the cows, which is really short. In commercial dairy, it's 5 years. It takes 2 years for them to have their first calf, so the productive age is only 3 years in full production, and then they get burnt out essentially. Which I have cows in there that are 12, 13 years old and make calves still every year. So that's a completely different stress level. Of course, they don't get milk, so the nutrient demand is way less, right? But so going away from intensifying animal use and then intensifying land use to extensifying that and making it more sustainable. But there will be societal cost implications for that, and that's really the sales point that we haven't reached yet. Europe, at this comparative income levels, spends about twice as much of their average income on food than the US does. That's because it's so much more. They're on a slippery slope to getting here, right? We're talking about Alameda, Spain. You know, it's I don't know how many thousands of acres under glass. You know, which is like sort of the Central Valley of Europe, where all the greenhouse stuff gets produced, and you know, African immigrant labor gets exploited, and you know, instead of Mexicans, it's North Africans there. And it's you know, so it's not like they have figured it out, but what they have figured out that there's a culture around food and also more equitable distribution of wealth in society still, even though it's going in the wrong direction, that enables people to buy better quality food and pay more for it, and so that makes for an overall more sustainable system. And so the commoditization and the structural impediments of the intermediaries in the food system here in the US is really where a lot of the blockage to change in the food system lies. And let's not forget, the food system is explicitly designed to be obfuscating and to hide. Like labor laws don't apply. They don't apply to agriculture. That is the huge exemption that came at the end of slavery. Essentially, the South said, yeah, we're forced to go along with this, but we're not going to apply labor laws or minimum wage laws or any of that to it, thereby perpetuating, in effect, the same societal system, just not calling it the same. But I mean, that's why the tomato workers in Kissimmee, Florida, you know, this was the big, what is the movie called? Work chains or something like that. You know, where they striked and stopped supplying Publix, and they wanted to double their pay from 2 cents a pound to 4 cents a pound. And that would have increased the price of the supermarket tomatoes by 2 cents, right? And it would have doubled their income.
Publix won't sign.
No, I know.
It's crazy.
It's absolutely crazy because it's ridiculous. 2 cents is absolutely nothing. There's no impediment, but it's exactly those middle, that the distribution chain that holds the power and can exploit the system up or down to the consumer and to the farmer and squeeze both. And that's where the regulation has to go. That's where the legal framework has to change. It's the same in the dairy industry. You see it all the dairy companies are doing fine. It's the farmers that aren't doing fine, right? We've lost 150 farms in the last 3 years in Vermont, dairy farms, and still this is with pumping an average of $80 million into subsidies for dairy farms every year, just in the state of Vermont, which is absolutely crazy because it's not sustainable what they're doing. So, you know, doing something where we change the system and then finance that to make it more sustainable and lower the cost base and the exploitation of land, so there's a win-win for both the farmer and the land. That's the way forward to keep dairy here. Otherwise, we're just not competitive. Our landscape is not competitive. Except for certain swatches of the Champlain Valley, we don't have the acreage, and you can't take cows like that. You can't have a 10,000 cow dairy, and like there's organically certified 10,000 cow dairies in California, Arizona. I mean, in the most arid landscapes, they have center pivot irrigation. They harvest that. They're not following the grazing requirements, the outdoor access requirements, and still they get certified. So there's also rampant corruption in the whole system.
And the organic farms here in Vermont are getting kicked off their co-op. A lot of them. It's happened this last year. A lot of Horizon farms got dropped in Vermont because they're favoring, you know, the distribution from more centralized. I think, what is it, in like Ohio or there's somewhere like Iowa, and so they'd favor milk that's, you know, from a much bigger farm closer to their distribution center. So they'd rather drop a Vermont farmer. Okay, so before we head out, if there's like one thing, whether it's like a fundamental thing or like a really specific thing about the way that the government pays for conservation that you would shift and change, what would it be? Could be two things.
Well, I think I would really like to see the system shift from a prescriptive system of saying you do A and we pay you B to a monitored results-based system, and also taking into account where's the starting point, where's the end point, what has the journey been. You know, it's like I've done a lot of stuff that I'm never going to get paid for just because I started with a different philosophy. That doesn't mean that, you know, under the system in theory results with me getting paid less even though I'm doing better work. And rather than somebody who's in a completely abused state of land management and then goes from there. So we need to equalize that somehow and reward the farmers that are already doing this stuff better or more, to say, you know, how, let's take that model and replicate it. Can we pay you for doing that? Like, you know, have other farmers come here and show them, or, you know, whatever the system is. And then it's like, I would like to see like the monitoring of the stuff that, you know, I think there's a real benefit to science there. And right now, a lot of the payments are just tied to sort of checking the box off. Yeah, put a bird box off. The bird's never moved in because it's facing the wrong direction. You know, stuff like that. It just falls through the cracks. And in general, it's also continuity. That's been a little bit of an issue where we really like to see. There's a lot of turnover of young engineers at the ag department, and they come for 2 or 3 years and then they leave, and the successor doesn't, like, you know, it's like agriculture has just longer cycles in terms of, you know, accountability and seeing results. It just takes a while. You know, you're not going to change something in 6 months. You're going to change it in 3 or 4 years. And if that documentation doesn't come through, then it's really hard to see what we do.
But that comes down to our technical service providers being paid a competitive wage.
Right, exactly, and it's not some administrations that's nilly-willy firing half their staff and moving the ag department to I don't know where,
Kansas.
You know, that all plays into that. So as long as we don't have an overall commitment of society to become sustainable, and you know, we define sustainable. What is sustainable right now? Look at agriculture. We say it's such a, you know, thrashed word in that sense that it's been bantered about. But if we go back to sort of where native cultures, you know, if you look at the Iroquois Confederacy, they define it as 200 years. And so that's 7th generation. That's the famous toilet paper brand, right? That's where that came from, the 7th generation.
Oh.
And so if we look at 7 generations, if we do things so that in 7 generations it's better than when we started it, that's really the perspective we need to have for natural systems. And we're nowhere close, policy-wise, to support that. We're talking, you know, policy-wise, we're looking at 10, 15, 20 years maybe at most. Most contracts of the RCS are between 3 and 5 years, which is a great start, but we really need a 200-year perspective if we want to survive on this planet. And if people want to fool themselves and say agriculture isn't fundamental to that, you know, oh, we need technology, this and that, and we're going to survive on Mars, well, I don't agree with that. You know? We need to eat, and this is where food comes from, and no lab-grown meat or, you know, impossible burger that's growing with soybeans imported from China is going to fix that, right? I mean, the vegan ideology is actually an interesting starting point for a conversation, but it's a delusional religion. I'll say it right out like that.
I wondered if you'd talk about veganism.
Yeah,
I didn't know anybody bring it up. But.
It comes from a fundamental disconnect of how food production actually works. And the sad thing is that the urban voice has been so magnified in terms of where the population has shifted. And I think there's a good intent and a good heart there, but there's a fundamental, they just don't get it. It's like, can I show you what I do? Okay, I have 40 cows there. Each of them produces about 450 pounds of meat when they're boxed in the freezer. And so that's a lot of calories with lives, very few lives lost. If I'm looking at the overall impact of how many mammals I kill, how much biodiversity I kill, we're fostering biodiversity here. This is not plowable land. Well, some of it is maybe, you know, in further reaches, but anything over 8% slope is not considered plowable by the USDA, or only with mitigation and really careful management practices because of erosion. And so if we look at the overall available land in the United States, the best land is actually where all the houses are, because it's super convenient. So we already lost a lot of that. The second best land is the one we should be using for vegetable production and grain production. It's the flatlands and rivers and, you know, plains and stuff like that. And then all this rolling grasslands and steep slopes and stuff like that, that's all animal agriculture. And we want to eliminate all of that. What are we going to do there? We're not going to rewild this into some fantasy pre-colonial wilderness, which never existed. But you know, there's sort of that draw to do that. The Sierra Club vision of like have one huge national park with like human islands in it. I mean, I'm oversketching something here, but I think you guys get the idea. So what is really our philosophy to have a regenerative system that is long-term sustainable, and it has to be based around animal agriculture. There's no other way in our climate zone to do that. When we don't live in Kerala, India, where the fruit grows everywhere and you're fruitarian. That's great. Life expectancy isn't great because the nutrient balance isn't there. So that goes back to Weston Price and all that work about nutrients and what is an indigenous diet and how can we adapt to that to sort of have optimal health. The USDA has stopped monitoring the nutrient density in fruits 4 years, 5 years ago. The apple a day keeps the doctor away. That came from the 1930s when they started saying this is the amount of vitamins in an apple, and you taking that dose of vitamins every day, you're good. Well, that apple a day, when they stopped 5 years ago, was 5 apples a day. Why? Because they look great, but there's nothing in it. And so this is really where we need to focus, is like, how do we get the density of nutrients? We eat so much, and we have all these processed foods, but it sends our bodies the wrong signal because they never get satiated with what they need. And so you have this constant craving for stuff because you're not getting the nutrients. Of course you want to eat more Twinkies. And it's like your body keeps wanting to have more of that sort of reward and saying, okay, but then anyways, it's all connected, and that's really, there's some understanding out there, but how to translate that into regenerative sustainable agriculture, a vegetarian or a vegan diet is not the way to go. We can't get the nutrients, and it's destructive to the environment as hell.
Thank you so much.
I know, thank you. This was wonderful.
It kind of was a fulfillment for her of a dream of putting together, putting into action and practice what you're working on even a global scale in Dana's case. Just a little bit of history on her quickly. She worked with a team of people back in 1972. She was originally trained as a chemist, but she early on got very interested in systems thinking. And she and her husband Dennis worked with a team at MIT back in 1972, back when computers took up an entire floor for a single. I got a feeling he didn't mean to do that.
Probably not.
They did the first kind of computer modeling to look at what if current rates of consumption of resources in 1972 continued at that pace or just about 1.6 in 2020. So they were amazingly on target with a lot of their visioning, and that kind of set her on fire with a drive to really be part of what was then the sustainability movement. And she devoted the rest of her life to that. She was the first woman professor at Dartmouth College and the first environmental studies professor there. But she worked also on a global scale. She was a very influential and deep systems thinker and writer. Helped form the Balaton group, which began working on this global sustainability issues back in the 70s. But anyway, Dana helped found this community, but unfortunately passed away at just 60 years old in 2001. So we kind of had to carry on her vision without her here. But she kind of recruited my wife and I, Carrie, to be the farmers chair in her vision of a community based in sustainable principles and with working farms at the kind of heart of it. And so that's how we came to be here. And we worked with the Vermont Conservation Board and the Upper Valley Land Trust to come up with a deal where the VHCB put up money and the sale of the development rights by Cobb Hill Co-housing also put up some money into to make a unit here affordable for a farm family and allow us to have access to the agricultural land here. So Cobb Hill is about 275 acres. About 200 of that is in the forest. 15 of it is carved out for the co-housing development. maintain those agricultural fields for perpetuity. And so we as young farmers then had access to affordable housing, access to land, access to markets that really fit with the kind of small, diversified niche product that we were hoping to develop. So it was a really great model, I think, one easily replicable, because not everybody wants to live in an intentional community, but one that does have at least could be part of the solutions going forward. It certainly has worked for us. And so early on, we worked with Agency of Natural Resources and NRCS to see if we could develop a what is it called? A biosystem to absorb the effluent from our milk house and dairy plant. So like a living wetland. Not a living wetland. That's not quite the term. But anyway, it's there's an organic farm by the Vidal that kind of has a model of this, that we were hoping that there'd be a place where we could create a natural wetland to filter the gray water from the cheese plant and the dairy house. Unfortunately, because of the degree of development around us and how sandy and porous our soils are, we weren't able to come up with a plan. But that kind of got us on the radar of NRCS. And so when we came back a few years later, looking to see if there was any funding for a bedded pack system for housing our cows, they came out to talk with us. And at the time, NRCS wasn't funding bedded pack housing for cows, but now they are. I guess we were ahead of the curve a little bit, because so the bedded pack was something that we had to finance on our own. It was the first time that, as small farmers, we just kind of got to the point where we didn't have off-farm jobs anymore. And what did we do? We went out and took on debt, because that's what you do when you're a dairy farmer. But anyway, so we did build this bedded pack barn, which we'll go through, and it's considered a more climate-friendly way of housing the cows, and it's also really a great way for, in terms of, I think, from the cows' point of view, because they have to be housed all winter indoors. Being dairy cows, we don't. Some people do keep dairy cows outdoors, but we don't subscribe to that practice. So if you're going to keep cows in a barn, this is kind of like the best, most comfortable way for them. They're free to move around. It's a comfortable service. They're not on concrete all the time. Just get up and eat when they want, go back and chew their cud, go get a drink, go groom your neighbor, whatever, it's a lot of great opportunity for cow comfort and sociability when they have to be in confinement in the winter months. Then they'll hang out there a little bit when they come down to get milk this time of year. It's a little cooler in there on a day like today. But anyway, so we paid for that, and it's the way it's a climate-friendly solution is that you continually add sawdust or shavings, sometimes as much as 3 times a week in the winter, and let it build up. And so all the manure and urine is captured in what is essentially a big compost pile that you're keeping nice and clean for the cows by continually adding fresh material on top. And then we also do scrape their feed alley, which takes out the raw manure that would accumulate that way, and then puts it into storage, which we'll talk about because that's one of the practices that we did get help for. So that when we go to clean out that pack barn, which we usually do 2 or 3 times a year, it's already partially composted when we take it out to our stacking pad, which is another practice we'll talk about. So we really like it. It does require more bedding than like a freestall situation, and that is an expense. But we also look at the shavings and sawdust as a fertility input to the farm. It's massive amounts of forest carbon that we're bringing in, importing into our system, and then composting. It's really the carbon base of our compost, and then that's what's going back out as for nutrient cycling back onto the land. And we also, by the way, end up selling quite a bit of finished compost to other market growers and serious gardeners, and there's many ways you can play with the numbers on the farm, but we can, on one hand, we can say that selling our surplus compost pays for the bedding. So they kind of, not that we get ahead, because you never expect that a whole lot when you're a dairy farmer, but you do. Anytime you're releasing something that's a positive for the cows and for the land, and isn't costing money. All right, that's approaching success.
What did you call the building?
So it's a bedded pack barn, and we'll take a walk through.
Yeah.
In fact, we could go. So I just, in terms of water, what we ended up doing with, because I should probably back up and just introduce that we have. So we lease 60 acres of land from Cobb Hill. About 40 is very steep pasture land, and the other 20 is what's called tillable acres, but it also includes the farm headquarters. So we also have a lease of the old farm buildings. And that's a free lease, but we needed to have a lease in order to work with credit union or NRCS or insurance or anything like that. So legally we are an independent business from Cobb Hill called Cedar Farm. And then we also operate Cobb Hill Cheese, which processes about 65% of the milk that we produce here into artisanal, handmade, aged raw milk cheeses. And we've been doing that for about 20 years. We're milking generally between 20 and 25 cows. So by industry standards today, we're really a micro herd. And one of about 50 cheese makers. And that's anywhere from even smaller than us to Cabot cheese. In terms of once we got the plant established for making the cheese, for having a bulk tank, we had to have some place for our wastewater to go. So we ended up having to put in an in-ground filtration system, but we did a somewhat progressive system called a Presby Maze system. And this was independent of any government help. But before the leachate reaches a mound, it's been filtered through a bio filter that takes out and helps break down a lot of that effluent, so that it's not quite as raw when it's going into the mound, into the ground here. Again, we're on a very sandy loam here, so we're very aware of water quality and how things are going to perk here. So why don't we could take a quick walk through the barn so you can see some baby animals, and we'll go out to the pack barn, and then if everybody's feeling good about being in the sun, we'll take a little walk out on it, look at some of the systems we put in place out there.
Okay, perfect.
And if I get to talking too fast, I'm open to any questions, comments, anything.
Yeah, you have a whole.
Yeah, me too. I'll try it.
Chardonnay was just born yesterday. So if you look here, you can see.
Oh my goodness.
Sorry, I think
That cow really holds still.
Yeah.
Look at how proud
Yeah,
she
she's gathering
looks.
dust.
You have
That's
such a
awesome.
beautiful baby. Look how cute the baby is.
My wife runs a 4-H club.
Oh, nice.
She take that with them when they go to the fairs and stuff.
Good for them. I think 4-H is really great for everyone. Yeah.
Actually, this is one of my daughter's show cows here, so she's very happy with this.
What kind of
heifer.
cow is she?
So most of our cows are Jersey cows.
Oh,
Yeah, you'll see one Holstein. My daughter shows cows, and so she has her own little mini micro herd within our herd of Holsteins.
Baby girl. Her nose is so cute.
The swallows have built a nest right up above that upright beam there, so they're zooming in. There's like 4 little ones in there right now.
Aww.
Oh, I love her. Oh, it's so cute. It's a baby.
She just had him yesterday. Oh, wow.
Thank you. Thank you for these medals. These are hands, not an udder. I'm sorry. That's little cows in there.
We've been breeding some of our cows that we're less likely to want heifers from to limousine. It's a British type of beef.
Oh yeah.
Yeah, it's just something that we've just been trying the last year or so.
Yeah.
Because we raise all our bull cows as steers here as well.
Okay.
So we end up actually selling quite a bit.
Yeah, nice. Come on through.
Slaughter. And we used to sell some to Hartland Brewery, but mostly it takes all the moves right through our farm stands. It's amazing. Really a local demand for it.
Yeah.
We're not exactly on the game.
Maybe I'll get extra ones.
Yeah, they just
Yeah.
still visiting. Niko's farm, where I guess probably the cows do stay out all the time because they're beefers. We're a grazing farm too, but of course because we're milking the cows, they come back in twice a day. But right now they're out on pasture. Fortunately, the pasture they're in has access to a nice shady spot right on the fringe of the woods, and I'm sure they're all in under the trees right now. But they got out and got their fill of grass this morning. So we're you know, because we had talked about this barn, I just wanted to see it. And then, so this other building here, I guess it was in 2008 that we began contracting with the NRCS Equip program. And on the basis of asking for help with this building, which they couldn't help us with, but then they said, yeah, but I think there's a whole bunch of other stuff around here we could help you with. And once they got going, we really started rolling. So we ended up doing actually 10 years of contracts with them on a whole variety of projects. And it was a tremendous boon to our farm overall, I'd say. So as a small, diversified farm, the infrastructure that they were able to help us out with was basically transformational, especially in terms of our ability to really become a management-intensive grazing farm. But it also was great in terms of our manure management and handling of manure, and really helping us develop both infrastructure and a system for doing that that was more effective than what we had been doing in terms of making good quality compost and having a workable way to responsibly deal with manure all along the stages. And one of those things was this tunnel out here, which is a manure storage tunnel. So you can see it's similar in design to the bedded pack, probably you know, just a variation on the theme, but we scrape through here every day because the cows, when they're in the barn, will deposit quite a bit of manure, and particularly in the winter. And then all the little pens, and I don't know if you saw, there's even more pens in the back with the baby calves who are not with their mothers anymore, but are still drinking from bottles, so they're all in kind of the nursery back there. So all those pens, it's part of our daily chores, is cleaning out all those pens, and all those wheelbarrows end up in that tunnel as well. And over the course of a winter, it adds up to quite a bit. Each fully mature cow is producing about 6 tons of manure over the course of the winter, each cow. And we've got probably 30 mature head, and we've got 70 total. So when you're milking 20 to 25 cows, that translates with all your young stock, and because we keep our steers as beef animals, to about 70 total, 65. And so in the deep of winter, it can be really hard to be trying to get manure out to our stacking pad where we're doing the composting. So having a deep winter area where we can warehouse manure in a way that it's not getting rained on and snowed on and with a lot of leachate, particularly when it's in that really raw form.
Do you have like a flood control system around it?
We do have fly tape throughout the barn area.
Did you say flood or fly?
Flood.
Oh,
Oh,
flood.
flood.
Yeah.
Flood mitigation? No, we don't.
Okay.
Yeah.
Has that been a problem that you ran into at any point?
Yes, it has been. So sometimes in February, late February, early March, we've been in a situation where the ground's still frozen, and we get one of those rain events where it rains more than an inch, sometimes 3 inches of rain, and this is, I think, definitely a climate change-related phenomenon that used to be a lot of snow coming down at that time of year, but sometimes you get a cold snap and then it whiplashes warm and we get this rain, and then it immediately whiplashes cold again and it's frozen. And we've seen that a lot during the last 10 to 15 years. And in that situation, we can get where this alley is withstanding water for 3 or 4 inches for several days, and it's a real mess. And we don't have a mitigation plan for that. Fortunately, the cows are at least high and dry on their bedded back, and we do the best we can to move that water out. But that's probably happened 3 times in the last 12 years that we've had that, where we had standing water for 5 days, 7 days in here. It was not a happy situation. The only thing that NRCS did for us, because water's coming down, we do have a concrete berm that we can see as we're going out of this barn that does serve as a bump to keep water that's coming down the road from coming down into the barn here. The problem is the water that comes into this yard when you get that kind of rain event. It doesn't seem like a very big area, but when it's an inch or more of rain coming off all those roofs. So Bill Van Fossen, who was our engineer, looked at that space and thought every which way, how can we put a roof over this? Because the goal for winter housing for the cattle is to really not have them out in the open under cover. This kind of cover actually does let through enough UV that they get vitamin D. So that's a really good aspect of this coverall compared to them being under tin. But preferably, the NRCS would like us not to have a cow yard where the cows are pooping outside and rain is coming and that's potentially leaching off. But they just couldn't figure out a way to put a roof over that. He pretty much, he was working on it when he retired. He's probably still waking up in the morning. How could we do that? So our new agent, Stephanie Lopez,
I think.
I can never say it, but
Stephanie.
is got it on her radar.
That's good.
So just see if she can think of something, because that would basically cure that situation for us. Now, what we do have from NRCS around all of these buildings is a drainage tile, and so that does allow the rain shed to not mix with any manure that's in the barnyard area, but to move more quickly, and that takes it out to the center of the hayfield out that way. So that's really helped with standing water, but of course that doesn't help in that winter situation where everything's frozen. Yeah. Any questions? Yeah.
When was this cow by itself over here?
Oh, she's one of my daughter's show cows.
Oh, really?
And,
Cool.
And our veterinarian's daughter, who's also a veterinarian now, but grew up showing cows, is my daughter's coach in showing at the fairs and stuff, and she's coming to help her work with
Oh, cool.
this
That's
cow
awesome.
and a couple others. Yeah.
Cool.
I thought she was pregnant.
Yeah.
I thought she was too.
She's pretty fresh. Yeah. Meaning she just had a calf quite recently.
Oh, she did.
Yeah. And these guys are in because they're dry cows, and we really like to manage more carefully their diet. Jersey cows are particularly vulnerable to metabolic disorders right around calving time, and so if you can kind of more control their diet and make sure they don't get actually over-conditioned, the issues around mainly calcium and if they aren't regularly accessing calcium from because they have a really good condition, then when they all of a sudden start making a marathon runner whose calcium and phosphorus and magnesium are all out of whack. So just keeping them on a more of a restricted diet really helps with that. And then some of these younger animals just aren't old enough to work with a single strand electric fence yet. So they're kind of schooling their way up. Once they're bred heifers, usually that's when they'll go out with the herd. All right, so good luck with it. Yeah. A marathon runner whose calcium and phosphorus and magnesium are all out of whack. So just keeping them on a more of a restricted diet really helps with that. And then some of these younger animals just aren't old enough to work with a single strand electric fence yet. So they're kind of schooling their way up. Once they're bred heifers, usually that's when they'll go out with the herd. All right, so good luck with it. Yeah. To do that, but I just talked to Phil and he saw, yeah, this totally makes sense until he figured out a way to write it in, even though it wasn't like an approved practice, so to speak.
But they counted it towards your concrete.
Yeah, so it just kind of shows how just having a good working relationship with the agent is so important.
And how having good engineers is so important.
Yeah. Yeah, really. Yeah, because it's
that was
service.
the last thing we were talking about at Niko.
Yeah.
Having good ag engineers that
We can stop here.
stick around. Yeah.
Yeah, exactly.
So a few of the practices that we worked on equipped with are visible here. There you can see our stacking pad, which is kind of a improved surface. There was an option to go with cement, but to me that just felt a little bit too permanent to put out on the middle of an ag field. So we went with road fabric covered with about 9 inches of compressed gravel. But it's about a quarter acre. It has a concrete berm on the back made of blocks so that when you go in with a bucket loader to pick up material, you have a backstop. And the reason it's right out smack dab in the middle of this beautiful ag field is because it was the only place outside of the well circle with all the developments around us. There's different housing. And so ideally the stacking pad would be right near where the manure is being generated.
But you remember all those setbacks that we were talking about, so yeah.
Yeah.
You saw these diagrams of how far you need to be from the house.
Yeah, and with our really well-drained soil, that kind of those circles really expand. So this is an improved road out there, even though it doesn't look like much. It doesn't become a mud wall in the wet times of the year, the shoulder times of the year. Not too bad because it is an improved surface. And so then having that place to receive the material. You can see the stuff on the far right is the most raw, most recently taken out material, and it just gets progressively turned to the stuff on the left, which is really the farmer's gold. That's some really good finished compost there. It doesn't even have worms in it at this point because they've done their job. Sometimes you get a compost and it's full of red worms, and that looks great, but it's because they're still working on it, you know. So another practice that we have very visible here is the irrigation. So initially we started out with a pretty large market garden, about, relative to this area of about 6 acres. We shrunk it down to 4 and did that for about 15, 17 years. But it was really difficult because we developed a well out there. We have underground electric cable all the way out to it for irrigation, but it was very limited. And when we got into a dry spell, we had to move 2 rain towers literally all the time to get the garden watered in a week. like every 2 or 3 hours we'd be out there moving pipe, and it was barely adequate because a well that's 500 feet deep has a 1-horse pump 500 feet down the ground. It's only going to be able to move so much water, no matter how much water is down there. So one of the contracts we were able to work on with NRCS was an irrigation system. It was contingent on us building a pond. They'd give us the in-ground infrastructure and the pipe and the overheads, the whole deal, but we had to dig the pond. And fortunately, first the guy in town that we got to know really well, who we hired to do a lot of our contracts, the heavy equipment operator here in town, is somebody who's worked so much. He inherited the business from his dad, so he's been an earth mover his whole life. And he looked at the wet spot at the toe of the hill where we always thought if we were going to build a pond, this is where we would do it. And he said, I could build you a pond there. And all the other engineers that we had hired had told us $50,000, $60,000. It was going to have a liner. It was just beyond scope. And Matt, kind of like a permaculturist, said, there's materials here that we can work with. You've got a lot of clay off that hill. And so he dug a pond. It's like 12 feet deep, even though it's only about 25 feet across. He lined it with the existing clay materials around this big Byrne bank that he'd made. Managed to save a bunch of trees around it too to help hold it. And that was 7 years ago now. And it always holds water. It's spring fed. However, when we actually use it to irrigate, because we have the well there in a dry year, when the springs are drying up, we can restock it off the well. And because we've shrunk our market garden down to about 1.25 acres, maybe 1.5 acres counting the high tunnel, we can get 1 inch of rain to the garden in probably 3 days. And we're going to invest in pipe so that we have enough pipe for every 1/4 acre section so that we don't have to move pipe anymore. It would be a very worthwhile investment to not have to move the pipe and just be able to turn the switches and keep the water moving that way. And the reason we were able to shrink down our garden was because we used to do a very extensive tillage system that we actually used. It was an organic tillage system, and we used our draft horses to do all the functions that a garden tractor would normally do, or a BCS, walk behind tractor. And we had a really great system, but we still felt like we were fighting the weeds all the time. And I began to hear and learn more about how traditional organic tillage, even though it puts in tons of compost, lots of cover crops, that we were doing all those things, it nonetheless really relies on a lot of soil disturbance. And that really creates more of a microbial dominated soil. And when you look at what was here, you had ancient old growth forests that were a fungal dominated soil. And it was this extremely healthy, complex, biodiverse environment. And so when we started thinking about how going forward can we look back at what that was and begin to restore this land to that kind of health, then we started thinking about these no-till systems that are coming out. And so we have been transitioning over the last 2 years to a zero tillage, no plow, no cultivators bed system. Because we're a dairy farm and have all this abundant compost, we can use it as a mulch layer, and that prevents weed germination and just slowly feeds that compost to the soil, but allows those fungal and microbial relationships to reestablish and soil aggregation to happen without the continual disturbance and actually destruction of those systems with our tillage implements. So it's kind of looking back to ancient ways. Many traditional and indigenous farmers have used these methods, but then using the new science of soil microbiology that's coming out to understand from a different perspective how we can really enhance those relationships. That's kind of a
Do you have any problems with like having too much carbon from the mulch?
It's a pretty new system, but we were putting an equivalent amount of compost onto the soil when we were in a tillage system, like 20 tons per acre. which is pretty typical of organic farms. And as I'm sure you know, Jennifer, a lot of organic farms are coming up against a situation where they're finding that the reliance on compost is leading to actually a lot of phosphorus in high phosphorus levels in organic soils. Now we're a fraction of the acres in the state, so it's not as big an issue as dairy farm phosphorus runoff or anything like that, but it's still something that is getting onto the radar of the organic farmers. How can we mitigate, how can we make sure we're not part of the phosphorus pollution through our, trying our best to steward soil? And my feeling is that when you incorporate the compost, you get a really big flush release of nutrient, including phosphorus. Because
so by
you
incorporate, you mean like till in,
till it
turn
in with a
into the
spade
soil.
or a rototiller or a plow. You get air, water, nutrient, and it's almost like you create a fire, literally a biological fire. And a lot of that nutrient, particularly the nutrient, can burn off, volatilize in that first 24 hours before it can get fixed into humus. Whereas if you're applying it as a mulch, it's more like the duff that accumulates in a forest over time, and on the top it's quite raw and actually makes a mulch to help hold in moisture, and then as you go down it's becoming increasingly digested by more and more until you've got basically plant food that's turning into aggregates and that high roots are feeding from. But it's a much slower process of introducing nutrients, I think. So that's the theory with
So
this.
over time,
Yeah.
it's going to be
And
Short term, you might get some initial like shock.
I think what we saw last year was that we had two distinct layers. We had mulch and we had the soil below. This year we're already seeing that earthworms and beetles and all the microbiology there's been this carbon cycle kicking in, and there's exchange between those layers now, and so things got going even a lot faster for us this spring. And I think even that biology over time actually gets you going quicker in the spring. And the other thing is that we're just seeing as we reapply the beds, and we're using other mulching systems too. We're using straw, clean hay, cover crops that are being solarized or winter killed. So a whole lot of different ways of bringing in carbon mulch material along with the compost, but that we'll just back off the compost as much as we can as long as we have that weed barrier. And obviously still always bringing in carbon, because if you're shipping off vegetables and you're shipping off milk and you're shipping off meat, you gotta say, I'm part of this carbon cycle, I gotta keep bringing it back in too, even though now we're relying more on photosynthesis to actually build soil, create soil through what's called the liquid carbon pathway of photosynthesis. And that's really the whole idea between the no-till, to just keep things as generative as possible. And so then in the grazing system, we're kind of doing the same thing. How do we keep plants generative for as long a time as possible so that photosynthesis, the driver of the whole biological machine, is maximized? So minimize disturbance, maximize photosynthesis. And so we're doing that through our grazing system by moving the cows every day. As you probably saw, Niko might be moving them twice a day even.
Yeah, I guess so.
Yeah.
Right? Yeah.
And always trying to leave behind like 50% residual, so that you're going to get really good healthy growth back. You're not going to be depleting the root systems, but rather getting generative growth going right away again to start feeding roots, and then extending that rotation for as long as possible, in most cases, to give a rest period to the paddock. So one of our paddocks, if we do 5 rotations in a season, actually only sees the cows for 5 days out of the 5 months of grazing season. So it's pretty relatively low impact. What has typically been done, and is still often done, is called self-stocking, where you might have the same 40 acres that we're grazing on, but the cows go out on there as high as they can in the spring, and when the snow starts to fly and it's down to a budding green and it's had no chance to regenerate itself, and it's actually shrinking rather than growing, and that's the carbon in the soil, is the root. So a management tool where you're really trying to use the cows as a management tool to improve your grass and your biodiversity and health of your soil, essentially. And it's tricky, and it's been a steep learning curve for us, but it's a great adventure to be on, trying to work this way. And recently we're working on keeping the cows out of what we've identified as micro lands out in our pasture system, and we're going to start introducing some tree species that like having their feet wet, to say that's not productive land for cows, but we can make it more productive land for the ecosystem in general, which will benefit the cows, the grass, the whole farm organism. And conversely, looking at some of the really steep parts of the property that were probably denuded of trees back in the merino sheep boom back in 1810 or 20, and probably never should have had the trees taken off of them, and have really suffered a lot from the kind of set stalking that we were talking about. So there's very little soil there, and it's quite acidic. So we're looking at how could we maybe bring some trees, particularly nitrogen-fixing trees, back into this situation to cool it, to help retain moisture, to help even start getting some duff on the ground, to help catching runoff and rebuilding soil in those areas. And we might even just keep cows out of them for a while as we get those trees generating. So those are some future projects that we're hoping to get some help for with the conservation stewardship practices, which is kind of the CSP that follows on EQIP. And we have gotten some grant money from the federal government that's administered through Niko, Vermont, and form of a resilience grant to get going with some of that tree planting this season. So we're really excited about next steps. And that would also include a native species hedgerow to separate the market garden from the grazing hayfield beyond it, which would be kind of like a 5 species minimum multi-story 30 by 150 foot hedgerow with berries that would be both edible for people and for birds, and hazelnuts, things that we might even potentially harvest but are going in there for biodiversity, and also to help create a microclimate in this pretty dry area here. So another potential project within our system getting going. So with the grazing, as I mentioned, we have 40 acres of fill pasture, and do you want to walk up into the grazing area?
Sure.
We can get to a little cool area for a minute. And, if we just double back this way, Jennifer, for a second. 25-acre maple sugar bush here that's still maintained, and so it's a fairly serious. They have about 1,000 taps. They can make as much as 500 gallons a year. But what's kind of cool about it is the guy who's sort of like the principal worker within it is an associate of Cobb Hill, but his aunt and uncle Barbie and John Hunt were the farmers here throughout most of the 20th century, and Ken grew up here, and he's about maybe 65 now, and he's been making sugar here. He's been sugaring here continuously since the 1970s. So kind of neat to go over when he's boiling over there in the sugar house and kind of holding court, and like people there with pickles and donuts and whatnot, and it's quite a scene. But they try to do that in
Donuts and syrup.
pickles and donuts and syrup. To the champion. So we have, as I mentioned, 200 acres of woods on the property too, which we're enrolled in current use. And so Carrie and I aren't directly responsible for managing the entire acreage, but we participate as community members. And we have a land use committee, and we have a forestry committee, and oftentimes those two committees get together, and we really try to look at all the different uses on the property, including there's a lot of recreational uses associated with our partnership with the Upper Valley Land Trust, and to like really get a holistic overview of how everything is working, all these different parts are working together, because it's complex to have this many people, a whole village situated here. But I think it goes pretty well, and the woods are, we are fortunate to have a forester who understands the principles of ecological forestry, who is overseeing our 10-year forestry plans with current use here, and really managing for more complexity, more kind of old growth like characteristics in the forest, identifying legacy trees. Now the thing about, I talked a little bit about what was here pre-settlement. We know that anywhere from 65 to 95% of the Northeast was covered in old growth forests. There were people here practicing what now gets called agroforestry and agroecology, both in their farming practices and in their recognizing the forest as food, basically. And evolving over 12,000 years, this completely reciprocal cultural relationship with their environment. Something that I think we really need to start paying very great attention to. So going forward then, if that's our past, what we came upon was land that, upon European settlement, was driven to almost ecological collapse by what European extraction, colonizing mindset was. And the forests were literally leveled. So many species like the eastern elk were driven into extinction, wolf, bear, mountain lion, all gone, beavers gone. So all these keystone species eliminated, the whole forest ecology eliminated. You can imagine what that did to the hydrology of the region, how much soil ran down the rivers brown. We always heard that New England was this place of poor, thin, rocky soils, but it was anything but. It was this, super organism of forest that had adapted to every topography, every microclimate within this region, and built this complex, highly biodiverse structure. And the forests themselves were extremely dynamic. I mean, in an old growth forest, when one big tree finally goes, you have a gap as big as a football field that starts regenerating immediately. And that's just a small example of how disruption and regeneration were really built into that system in a way that was self-organizing and self-building.
And so that's what we try to mimic.
Yes.
And
so
with the early successional habitat practice we looked at, I think yesterday or the day before, where you're basically cutting something, a swath out of the forest and letting it regrow. Because a lot of things like that, new growth, right?
Yeah.
It's beneficial, but we have to, fake it.
Right. Yeah. And so when we came here as young farmers in 1998, the dairy farmers who had been here before us were typical mid-size, milking 100 or 60 cows, had 110 total. Were making corn, silage, and hay all over town because they didn't have enough land here, and just wringing the heck out of everything because their backs were against the wall. The margins were so thin beginning in the late 1970s that, and they hung on for a couple of decades after that, even, with these oscillating but generally depressed milk prices, and yet all the fixed costs going up continually during that entire time. So by the time we inherited the farm, they were really good, hardworking people with a great land ethic, but they had beat the hell out of this land. They had set stocked all these hills, and probably people before them had too, so that all 40 acres were down to basically putting green. They'd probably done corn continuously on that land. They'd been told, you got to feed it NPK, you got to feed it atrazine. This is what they've been sold, so that's what they did. And so soil organic matter was at 3%, which often gets touted as okay, but 3% is really just about the threshold at which biological life can happen, and you get below that and you actually need NPK to feed plants soluble because there's not enough biological activity going on in that soil. So we need to be looking at 6%, 9%, 12%. We need to be looking at what the old growth forest was doing. But anyway, so when we started trying to graze this, and we had less cows and all this land, and it immediately got way ahead of goldenrod and ferns and stuff this tall. And we tried for about 10 years. We did not have water out here, so that anywhere we put the cows, they had to come back all the way to this spot was the highest spot that we could pump water to from our well. So anywhere else, they had to come back to this spot to get a drink. And you can imagine on a day like today, a cow doesn't want to walk a half mile for water. She doesn't want to walk 30 feet for water if she can help it, you know. And cows start to overheat above 70 degrees, so they're a lot more sensitive than we are. So NRCS came in, and so then we were doing set stocking. Basically, we had 7 big giant paddocks around. Cows would be on there for about 7 to 10 days on each one. We knew that ideally you get the cow off after 24 hours, and at the very least 5 days. After that point, the crown of the grass plant is going to start growing again. And if the cow comes back in and chomps that again, it's just going to, that's a major disturbance. So when we talk about not disturbing soil, it's not just the plow, it's that second, third bite on that crown is going to set that plant back. It's going to need root growth, it's because it can't just photosynthesize to rebuild, regenerate. And when it's drawing on root growth, it's shrinking rather than expanding and feeding root growth.
That was something I only learned recently. Like what's happening on the top is below.
Yeah.
If it's growing up, it's also growing down.
Yeah.
But then vice versa, and the roots actually shrink during overgrazing.
Right. And you hear about like old, you know, like you know, so here I look to old growth as our benchmark, but if we're out in Illinois and looking at what is a short or tall grass prairie and roots 9 feet deep, you know, I mean, wheat plant, you know, soy plant, corn plant, you know,
Pick it up.
you know, tall grass prairie, you've got that loose soils. Anyway, so same thing here. Grassland isn't natural here. Anywhere that we have a farm field or a pasture, we've borrowed it from the forest. I didn't understand that for the longest time. Oh, this is a field, you know. But as soon as you don't do something with that field and the forest starts reclaiming it, like succession is underway the minute the human being turns our back on it, you know. It wants to be forest here. So how can we work with that to regenerate this landscape and at the same time feed our cows healthy, nutritious grass? And so that's where, for me, the reintroduction of agroforestry into these systems, I think, is going to be critical for climate resilience going forward, dealing with the flash droughts, followed by the precipitation events, followed by the flash droughts, the soft winters, all of it that we're going through now. We need to build in the forest resilience back into this landscape if we're going to you know, be able to have a thriving sovereign food system going forward. So that's what we're trying to build for here. But in the meantime, the NRCS came in and saw that we didn't have any of this infrastructure and said, we can help you with this. And it was huge, because what they did for us was they gave us high tensile perimeter electric fencing around all of the fields that we manage, including the hay fields, like that big field out there past the brook and the tree is one of our hay fields. And then they gave us this improved trail through here, and then we developed a spring up on the hill with well tiles and excavation, so that we have gravity-fed water that feeds the line that runs along this entire trail. So anywhere that we have the cows in the system, they have access to water. So those 3 things, that fence, the trail, and the water, then just opened up this whole new ability for us to do the managed intensive grazing. And we like to call it more these days adaptive grazing, because it's not just like we have 40 paddocks, 1.5 acres each, according to our grazing plan, that we rotate the cows through 5 times in the season and we're done. It's more like come out here and really try to understand what do we have here for forage. And there's a grazing stick and other tools you can use, but over time you also just get the feel. How much feed is there for this cow? 30 pounds of dry matter, which is 170 pounds of wet matter that each one of those cows is going to have to take in off this field if she's going to get her full nutrition off the field today. We do supplement with grain on our farm, but like Niko, for instance, I think it's 100% grass fed. And so by doing that, we're responding to the weather patterns, responding to what we think the weather's going to be in terms of how much residual we're looking for in a paddock before we put the cows in, and how much we want to try to leave behind when the cows leave. And it's so it's kind of not just a formula, it's a real pain. It forces the farmer to begin to really pay attention to what's going on with the living systems out here. And the cows then will respond. All right, I'm in a closer paddock. I'm going to graze over this entire thing. I'm going to graze it evenly. You're not going to have refusal areas where plants we don't want so much are, and other areas where it's grazed down to the nib because of being given hopefully just the right amount, more or less. And also the cow is then going to distribute her manure and her urine evenly over that hole. And that's critical because we're not getting up here on these hills with a manure spreader or, we wouldn't, but with chemical fertilizer. And so anything that the cow gets in terms of bought in hay or bought in grain, that's also a nutrient input onto the farm. It's not just helping her make milk, it's also bringing that mineral up back to the hills, bringing some carbon back up onto the hills. So that's the system in a nutshell, and really the one that, I'm really happy about all the infrastructure, but to me this was, being able to graze in this manner continues to be a transformational journey for us. Like we're not just, now we got this system, like we're really learning the system and getting deeper into it with each passing season and thinking about new ways to understand the ecology out here and how to restore habitat and biodiversity and make it from that set stocking denuded hills that we came upon to something really flourishing
So you mentioned agroforestry. Do you do that yet? What you would call agroforestry yet here, and where? And can you tell us a little more about
Yeah, so I guess to the extent that we have done that, it's been more by identifying areas to just fence the cows out 100% and let willows and poplars and red, dogwoods and things like that come back in. And that's what got us thinking about, we might even take a next step now of introducing trees. But for instance, that area there that you can see with some quaking aspen and balsam poplar just straight ahead of us, that's an area right out in the middle of the grazing pastures that we identified as a pretty fragile spring area where there's, except in the driest of years, actual water running out, bubbling up out of the ground in there. And we thought that could be a really cool habitat. So even when our pasture specialist, Kevin Kaya, we carved that piece out right from the beginning. And then on the basis of that, I've now started fencing out other wetland areas that just have some incipient willow and other species like that coming in, but that's where we're thinking we might actually go in and accelerate that process by bringing in some plants. Yeah, and then between the grazing land and the hayfield, you can see there, right there, it doesn't look like much, but there's a riparian buffer strip through there that we established when we did the fencing. And again, that was an area that it had a seasonal channelized brook, but that had been manually, with heavy equipment drained over the years. Fortuitously, a neighbor corrected a situation where water was flooding some of the subdivision by putting in an appropriate sized culvert, and that meant the water moved through much better for us. We decided we don't want to keep up with the channeling of this. We're going to let it go back, and it has now become from a straight sort of irrigation channel. It has become a meandering brook, and willows and osiers and a lot of other native species have come in. And
So you just stopped mowing, stopped allowing access?
Yeah, now it's fenced on either side of it. It's actually fenced out. Yeah, yeah, with the high tensile. And like elderberry. What's that? Not elderberry, but there's another tree species that has come in quite predominantly in there. So we didn't plant anything. We just watched it, and if there had been like a big invasive thing, we might have taken an action on it, but we didn't. And it's really, it's like a red-winged blackbird kind of sanctuary. It's a lot of songbirds, bobolinks are in there. The water has slowed down. It's cooled. It's meandering. So it's a really nice area. Another aspect of this is that because we have the hayfields fenced in, right around mid-July, August, typically you expect a dry, hot period at that time, and the pastures, the cool season grasses are really going to slow down at that time. So that's just the perfect time that if you have expansion room, you can extend your rotation, extend the amount of time it takes the cows to come back, and hopefully start to catch some rains and then some cooling and raining weather as we move towards September. So what we came upon was only making first cut hay, which is generally done right about now. So that field I still have to cut. And then we allow that recovery time. We also put compost on those fields each year. But in about 5 to 6 weeks, we're then able to fold those hay fields into the rotation, extend our rotation by almost 3 weeks, which really at that time of year makes a big difference on the pressure that we're putting on these hills and allows for better recovery time. And we looked at, all right, we could graze the cows 3 or 4 times for 5 days on this field, or we could get 5 days of second cut hay up in the barn off this field. Yeah, it was an easy choice. You know, we still do have to buy in that second cut from somebody else, and hopefully they're managing their land. And when we have a soil health protection and restoration act in the state of Vermont, we'll just know if I buy hay from you, you're gonna be farming ecologically too, because that's how everybody farms these days. Right? Don't have to worry about if the other farm has a negative carbon footprint or not.
Gotta improve on those RAPs.
Yes.
Yeah.
Yeah.
Why don't we head back, and if there are questions or anything along the way, and you can circle up by the bus, but I'm sure it's like 1 o'clock or something like that.
It's 2.
Oh my God, it's 2 o'clock. Okay, we gotta
And,
go.
you know, obviously, just think it's terrific that you're all interested in this subject and thinking about how you can apply it in your profession. So,
Thank you.
right on.
Yeah, thank you.
Yeah.